Video lecture on object-oriented system development lifecycle. The software development lifecycle contains a set of activities: analysis, design, implementation, testing, refinement. So it transforms the user need into a software which meets their requirement. By experience, few programmers or developers are applying various shortcuts and bypasses for developing a system, but that approaches are not successful. For actual development activity, we are able to see the code only after the 20% of the development time. So we have to concentrate effort on the analysis and as well as design. So in this picture, it gives you how the activities are carried out in the system development. First, the users needs to understand properly. Then they are transformed into the problem statement. Then the problem statements are converted into the detailed design. So finally, the detailed design are converted into the operation software which meets the user's expectation. So this phase clearly show the output of the one phase is the input for the next phase. The phase 1, which translates the user's need into the system requirement. The user's needs are properly captured and converted into the requirement specification or the problem statement. Phase 2 starts with the problem statement and end with the detailed design. So it contains a bulk of activities including the definition of how to build a software, its development and testing. So it contains the design description and the program details. So transformation tree starts with the detailed design and it ends with the system, an operational system which meets the user's expectation. So in traditional we are using a various model like a waterfall model. The disadvantage of this approach is it contains various phases. One phase is freeze, then only we are able to move to the next phase, as well as we are not able to backtrack to the previous phase. This is a major drawback. So everyone expect the software should be high quality. So the high quality software, the software should be developed with the minimal or no defect. So for high quality software, you have to ask set of questions like how to determine the system is ready for delivery, or the operating system satisfies the user need. Is it correct and operating as we thought it should? Does it meet the user's expectation? The four measures are given there: correspondent, correctness, verification, or validation. The correspondent means uh, the task process, how well the delivered system matches with the needs of the operation environment. The task of predicting the correspondence is known as a validation. So, uh, true correspondence cannot be known until the actual system is in place. Correctness ensures the consistency of the requirement specification and design description. Verification is the exercise of determining the correctness. So we have to understand the two verification validation. Verification means am I building the product right? Validation means am I building the right product? So verification ensures the consistency of the system with the requirement specification. Validation analyzes whether the requirement specification is correct. It is possible that we are able to develop a system which meets the requirement specification, but the requirement specification may be wrong. Object-oriented development lifecycle contains three phases: where analysis, object-oriented analysis, object-oriented design, and object-oriented implementation. The use case is the primary element. That's why it is known as a use case-driven approach. So the analysis and design and implementation, then the three phases, the use cases are the primary component. So in the use case driven approach, the use case model employed out of most activities of the software development. One can, by using this method, one can produce design that are tractable across the requirement, analysis, design, implementation, and testing. See, the use cases are used to the dynamic model like collaboration and sequence diagram, and the object model, and designing user interface and creating the test scenarios. The main advantage of the use case is we are able to produce the design that are tracked directly back to the user requirement, and as well as the use case scenarios become the test scenarios. The object-oriented development contains three main activities. One is analysis, second is design, prototyping, and component-based development and incremental testing. The task of the analysis phase is determining system requirements and identifying the classes and the relationship of the classes with the other classes in the problem domain, and we have to identify the users of the system, they are known as actors, and how they are using the system. So use case describe the user system interaction is a primary component of the system development, and as well as the object-oriented community adopt use case as a remarkable degree. So it shows how the object are interact with each other, how the object collaborate with each other to achieve a particular task, which is known as a collaboration, and it captures the user's goal. The use case model represents the user's view of the system. So it represents how the user is seeing the system, how the user is viewing the system. Once the use case model is better understood, you have to start identifying the classes and create a relationship between the classes. The next one is documentation. So 80-20 rule is there. The 80% of the tasks are properly carried out with the 20% of the documentation. So documentation and modeling are not separate activities. It is very essential that we should have a good modeling and as well as good documentation. A good modeling implies a good documentation. Okay. Thank you for watching the video. Thank you. So object-oriented design is discussed in the next video. Thank you.